Bienvenidos, Hushamdid, and welcome Anne Arundel Community College learners from the CTS-130 Section 402 course for the spring 2021 semester. This is the Cisco Networking Academy's ITNv7 course curriculum, or the Introduction to Networking course. And in this packet tracer tutorial, we're going to be taking a look at Lab 11.6.6, where we're going to be calculating IPv4 subnets. Now, this activity is going to be a little bit more difficult than the previous activity we completed, which was packet tracer 11.5.5. Because here, we're now going to be dealing with variable length subnet masking. We're going to be looking at different classes of addresses as opposed to a simple /26 with a class C 192.168 address. And so this is going to be a little more challenging of an activity. And so let's go ahead and dive in and see what this activity looks like. And so in the Word document, you'll simply type your answers in here, and then this is what you would save and turn in. And I'm also going to be showing you a very, very nice, I'll call it a cheat sheet, because that's what Jeremy Stretch, the creator of the document, calls it, at packetlife.net. And so I'll share that with you as we make our way through this activity. So let's go ahead and take a look at the first of the problems here. So that is the given IP address, right? Or here's the information that we're given. So the host IP is 192.168.200.139. We have the original subnet mask. Now, what they mean by original subnet mask is that is the classful mask for a 192. And if you remember back the activities we did with the Class A, Class B, and Class C addresses, they have default subnet masks. And this, in dotted decimal notation, is the subnet mask that is the default for the Class C. So when they say original, that's what they mean. Now, we take a look here. It says new subnet mask. Well, what they're saying here is that we've now subnetted this Class C 192.168.200 network. We've now subnetted it, and we've borrowed from the host bits, and we've made those host bits networking bits. So let's go ahead and dive in and talk about what exactly I mean when I say that. And let me pull up as our sort of whiteboard over here to the right, just a blank packet tracer screen. So now it's asking for the number of subnet bits. Now, don't interpret that to mean the number of total bits, and we'll do both answers. But when they're asking for the subnet bits, that implies that you are subnetting. And so if we are subnetting in this scenario, only in the last octet would we find the subnet bits. So remember, these decimal values that we see here have binary equivalents. And so if it's 255, we know that that means that all 8 of the bits in that octet, let's make sure we've got 1, 2, 3, 4, 5, 6, 7, 8, dot. And so basically, if all 8 bits are turned on, meaning they're ones, what that means is the decimal value is going to be 255. And so I won't draw the, and actually let's go, oops, sorry, 255 there, not 225. So we'll say 255 here, and then we'll do the 8 bits. And this is a classful, right? If it was a Class C, we would have 255, 255, 255.0. Now, if all of these bits, which are the host bits, are zeros for a Class C, it means we're not subnetting. We're treating it as if it was classful. However, the value here indicates that subnetting is taking place. Now, this is where our binary to decimal locations, or I should say the binary to decimal values, are based on the location of the bits. Remember, the first lowest order bit has a value of 1, and then 2, and then 4, and then it just doubles all the way up and I'll just come up here and say 128. So if we have a 224 as the decimal value in the final octet, what that means is we are borrowing the host bits to turn them into network bits. And so 128, and the next value over here is 64. So 128 plus 64 is 192, plus 32 would be 224. So 192 plus 32, I'm sorry, 192 plus 32 is going to give us 224. So if it is a 224 value here, it means that the first 3 high order bits, and remember, when you're in the octet, we have to go from left to right. We can't simply like jump over here and say, oh, well, I'll use the 1 and then the 2 and then the 4 and then try to come up with the value. You go from left to right from the high order bits, which are these first 4 bits, this nibble, and you borrow until you hit the value that we see here, right? So we've borrowed 3 host bits, leaving 5 host bits left over. So we have the 224 value we're looking for. So now how many total bits are used to represent the network portion of the address? Well, we can see it's going to be 8 plus 8 plus 8 plus 3. In other words, this is where we end up with our CIDR notation of a /27. And so you can see we've got the /27 here because 27 of the bits are used to represent the network portion. So number of subnet bits, and you could read this 2 ways. So there are a total of 27, and actually instead of doing that, which we would end up erasing at some point, let me do this. So a total of, and we've got, let me change the font inside here to make sure we get this, and let me do this throughout real quick here. Let's make sure we change all of that to Arial 12. Okay, so total of 27 bits are being used, and it looks like it's going to type it really small here for some reason. So I'll type the answers in and then I'll select it and make it larger. So total of 27 subnet bits is what we'll say. However, or total of 27 subnet bits being used, but we borrowed a total of 3 bits, or I'll say 3 host bits borrowed. And again, we can interpret this question in a couple of ways, and we'll go with that as our answer, right? So 27 total bits, 3 host bits have been borrowed, right? All right, so number of subnets created. So this is an interesting one. And again, I'm going to show you a super easy shortcut here that we can do by hand. So in order to come up with the total number of subnets that have been created by borrowing the 3 host bits, we simply take 2 and raise it to the number of host bits that were borrowed and that are now network bits. So we borrowed 3 host bits. So 2 to the 3 is 2 times 2 is 4 times 2 is 8. So our answer here will be 8, and I'll fill that in a second. And I'm actually going to show you how you can see each of the 8 subnetwork IDs and each of the 8 subnetwork broadcast addresses, and how you can see each of the available, usable, assignable IPs in each of those 8 subnets. All right, so we know that the answer, number of subnets created is 8. So now it wants to know number of host bits per subnet. Well, that would be the number of host bits we have left over for each of the subnets, and that's a total of 5. And so that's kind of easy to see. So total number of host bits is going to be 5. So number of hosts per subnet, so 2 to the 5. And if we take, we did 2 to the 3, right? So 2 to the 4 would be 16. 2 to the 5 would be 32. And so we're going to go ahead and put down 32. Now, that is the total number of IPs. Now, they're phrasing it here, number of hosts per per subnet. And what that implies is that is saying number of usable, assignable host IP addresses. And if that's what they're looking for, we need to subtract 2. And again, I should say that is what they're looking for. So we are going to subtract 2. And so there will be 30 usable, assignable host IPs per subnet. Again, it's 2 raised to the number of host bits that remain after we borrow from the host bits to get the subnet bits, right? To increase the number of subnets. And so we end up with 30 usable IPs. So now it wants to know the network address of this subnet. Now, the network address is commonly referred to as the subnet identifier or the subnet ID. So just like I say, a VLAN is a broadcast domain, is a subnet, right? Those things are equivalent. We're going to make an equivalency statement here. The network address is the subnet ID is the subnet, right? And so how would we figure that out? Well, for this, we need to know the block size. And the block size is very, very easy to figure out. We have it already. The block size is simply 2 raised to the number of host bits without subtracting 2. And it's that easy, right? So the block size becomes important because here's how we figure out our 8 subnets, our 8 subnet IDs, is we start at 0. So we would say 192, and again, what's implied at the front end of this .0 is 192.168.200. And so we would say .0. That is going to be our first subnet ID. And then we simply reference the block size. The next subnet ID or network ID would be .32. And then the next one would be .64. We just go up in increments of the block size. The fourth subnet is going to be .96. The fifth subnet is going to be 128. The sixth subnet is going to be .160. The seventh subnet is going to be 192. And the eighth and final subnet ID is going to be 192 plus 32, which is going to take us to 224, right? All values that we're very, very familiar with when we worked with our binary to decimal conversion. And so here you can see we have the 8 subnet ID values. So now the question becomes, okay, well, that's great. Well, what about the broadcast address? Because obviously they're going to ask me for the first usable IP, the last usable IP, and the broadcast address for the subnet in question. And again, when you draw it out like this, it's very simple and straightforward. We take a look at subnet number 1, and we say it begins at .0. Well, if subnet number 2 begins at .32, the last IP in this range, not last usable, not last assignable, and so the last IP in the range is going to be .31, the IP that would occur before .32. And so the gap in between here that we see, right? We've got this gap between .0 and .31 is our usable, our assignable, our host addresses, if you will. And that's how they're referring to them here, which would be .1 to .30. And so there is the entire first subnet. Now, I've played all of these out here. And again, we're going to circle back to answering this question. And the question we're sitting on right now is, what is the network address of the subnet in which this IP address belongs? And you can probably figure that out by looking here, but let's play this out. So the broadcast address will be the last address in the subnet. It's one less than the next subnet ID that's above it. And so here it would be .63. And this is easy to fill out now, .95. Again, I'm just simply looking at the next network ID and then doing one less than that for the preceding subnet. So this would be .127. This one here would be .159. The broadcast address for, and again, we'll say subnet number 2, subnet number 3, subnet number 4, subnet number 5, subnet number 6, subnet number 7, and subnet number 8. So 159, and then 160 would come all the way up to 191 because 192 starts the next subnet. And this is going to be .223. And then finally we get to this last guy here, right? Now this may raise some questions because we don't have another subnet over here, right? We got our 8 subnets. So here's how you would figure this address out. And it might be intuitive for you to figure it out and say, well, it's got to be 255, and you would be correct. Because remember, that is the maximum decimal value that we can get from any octet. With all bits on, the maximum decimal value is 255. And so intuitively, you might have sensed, well, that'll work. Because the other way you could sort this out is to say, if I added 32 to 224, what would that give me? Well, that would give me 256. And we know that we can't have a decimal value in an octet that's equal to 256. Because if all 8 bits are on, the maximum value is 255. So now we look at our different subnets here, and the question we ask is, in which subnet would I find the host IP 139? Well, it's going to be in the 5th subnet right here. And so now we have all the information we need to answer the question. So the network address of this subnet would be 192.168, excuse me, .200.128. The first host IP would be .129. The last host IP, the last assignable IP, would be .158, not 159, because 159 is our broadcast address. So let's go ahead and fill that information in here. So number of subnets created was 8. Number of host bits per subnet is 5. Number of hosts per subnet, again, we're talking assignable IPs, is 30. Network address of this subnet is 192. Boy, oh boy, there is all kinds of trouble here in this Word document. Let's fix this up here. So it's going to be 192.168.200.128. The first usable IP would be 192.168.200.129. The last host IP is 192.168.200.158. And the broadcast address is 192.168.200.159. And so this is our solution set for problem number 1. However, this was one of the easiest of the problems to figure out in this worksheet because, as we'll see, and I'm going to go ahead and erase this, so if you want to screen capture it, do it now. So let me erase the screen. Let's get control, and let's come down to problem number 2. And so here we are looking at problem number 2, and we can see that we have a Class A address. However, the subnet mask is not that very friendly and familiar /24 or greater, right? So /25, 26, 27, right? Where we're very familiar with those because that's what we've been working with. Now we're dealing with a Class A address with the default subnet mask of a 255.0.0.0, which has now been subnetted out to a /17. And so now we're going to be going into some unfamiliar territory in terms of having to come up with all of these values. And this is a great time to segue to the cheat sheet I referred to earlier. Now, if you have not visited or found in your travels on the internet the website packetlife.net, Jeremy Stretch is the individual who created this site, and he has created some of the best. He calls them cheat sheets. I'll refer to them as study resources, study guides, because they are absolutely amazing. And one of the study guides that he has on his site is this IPv4 subnetting sheet. And this walks you through, starting from a /32, which we refer to as a host route, and we'll talk about that as we progress in the course. And it shows you each of the subnets based off of /32, if all of the bits are host bits, meaning it's the host subnet mask, to a /31, to a 30, 29, 28. And you can see here in the column in the middle, it shows us the number of addresses, right? The number of addresses. Now, let me ask you, is this showing the total number of addresses? Well, here for the 31 and the 32, it is. With a /32, you have one host address. That's why they call it a host route in some cases. For a /31, you get 2 usable addresses. Now, these are a little outside our scope right now, so let's focus on the 30 and below here, where we see a /30, we get 4 addresses, meaning, and from this point down, from the /30 down, we subtract 2 to get the usable number of host IPs. But this is a very convenient little study guide to sort of help you figure out, well, if it's a /18, what would the subnet mask be? My recommendation would be to work the problem out by hand and then come back and validate the answers that you're getting to check to see, hey, did I get the total number of IPs correct? Did I get the subnet mask correct? And so this is a great sheet, packetlife.net. Again, I can't recommend the site highly enough. And so now let's go ahead and let's transition back to this activity and let's work out problem number 2. Move that to the side. And so as we take a look here at problem number 2, this is going to introduce some new challenges. Now, the method we used before with those little shortcuts I taught you about the number of subnets, simply raising 2 to the number of subnet bits that have been borrowed from the host bits, that's going to get a little bit more complicated here. Again, as we look at this is a Class A address by default. Again, another RFC 1918 address, a 10 dot, which we would use internal to our network. And then you have the default subnet mask for the Class A address, which is 255.0.0.0. And again, this would be a /8, where the first 8 bits represent the network portion of the address, and now the last 24 bits represent the host bits. And if we were to take a look at our cheat sheet over here, again, you can see that if we're talking about a /8, if I come down here, by default, you're allowing 16.7 million host IPs in your network. Well, that's pretty excessive in most modern day networks. And so what we're going to do is we're going to subnet that address. And you can see here is the new subnet mask that's being applied. It's a 255.255.128.0. And so let me pull up a blank screen here as our sort of to the right-hand side so that we can work this out and see how things are going to play out here. So number of subnet bits, and we'll again talk about the number of network bits in total, as well as the number of host bits and the number of subnet bits. So by default, we're looking at, and I'm going to go ahead and use an N here, right? We'll do 8N. So these are the network bits, the 8, and I'm just instead of using ones and zeros, I'm just using a letter N here to differentiate that these are the network bits, right? So here are the first 8 bits in the first octet of a Class A address. Now, We are borrowing from the host bits so that we can create additional subnets. In fact, it's going to be right around 512, or it should be 512 exactly. So if it's 255 in the second octet, we have then borrowed all 8 of the bits in this octet to become network bits because we want more networks. This right here is a single network. That is one network right there. 10.0.0.0 would be the network ID. 10.255.255.255 would be my broadcast address. And I'd have 16.7 million host IPs inside that range. That's really way too much, right? We don't need that many host IPs. So 1, 2, 3, 4, 5, 6, 7. So we borrow the 8 bits in the second octet here, right? So we're borrowing those 8 bits. So it's all 250, so it's 255 now, and then 128. Well, remember, in the values that we have in the 8 bits, it is the high order, or the highest order bit, the very first leftmost bit, that has a value of 128. Now, all of the remaining bits would be for the host portion of the address. And so we'll drop in the H's here that represent that. And so we've got 7 host bits here. But remember, there are also 8 more host bits in this last octet. So while we've created more subnets, we still have a large number of host bits available out here on this last octet as well. And we're going to add these together, and I'm going to do a little bit of math here, and we'll see what this looks like. So here is what the address looks like in terms of network bits represented by the N and host bits represented by the H. And all I did was take the subnet mask and represent it in a format that kind of breaks things down for us. So, number of subnet bits used. Well, if we don't count the classful 8 bits from the class A, the number of subnet bits would be 9. All 8 bits in the second octet, and then the first bit in the third octet. So, here's what we're going to put in for our answer here. I'm going to go ahead and say total. We have 17 total network bits, and now we're getting this new font even. And we have 9 borrowed host bits, right? So we'll put it like that. 17 total bits represent the network portion. 9 have been borrowed from the host portion of the address because we don't need 16.7 million addresses. All right, so number of subnets created. Well, the equation, or the little cheat that I showed you earlier, sort of a shortcut, is you would take 2 and raise it to the number of borrowed bits. So we would say 2 to the 9. Well, we know that 2 to the 8, right? If all 8 of these bits are on, we know that that would be, or I should say 2 to the 8 we would know is 256, right? Because you can go from 0 to 255 in an octet. So we know that 2 to the 9 is going to get us to 512. And we'll check this here just to make sure. So 2 to the 9 is 512. So we've just created 512 subnets out of that 10.0.0.0 range. Now, figuring out what those subnets are, this is where we might run into a little bit of a challenge here. But let's address number of host bits per subnet. Well, you can see right here, we list out the number of host bits, and it's 8, and then these 7, so 15 total host bits. So we would say 2 raised to the 15th, and that equals, and my guess is it's going to be 32,000, and again, I kind of work with subnetting a bit, so 32,768 is my guess here, and again, we'll confirm all of this. And so that's the total number of IP addresses per subnet based on the 15 host bits. And then again, to get the usable count, I would subtract 2, and we end up with 32,766. Right? So how can we check this? Well, this is where you're probably going to need the calculator. And anything above 2 to the 8, typically I'll pull the calculator out just to double check here. So let's go ahead and say 2 raised to the 9th, and let's confirm that. So 2 to the 9 is 512. If I clear my screen and I say 2 to the 15th, we should get 32,768, and we do. And so I subtract 2, we get the usable IP. So let's come back and fill our worksheet out. Number of subnets created. So we just created 512 subnets there. Number of host bits per subnet. Well, we know that there's 15 host bits. Number of hosts per subnet. And we know that that's going to be 32,766. Remember, here, when they say number of hosts, they're not talking about total number of IPs, which would be 32,768. When they say host, they mean how many usable, assignable host IPs are we talking about here? Now, it wants to know the network address of this subnet. And so here's where it might get a little bit tricky, because the little shortcut that I showed you earlier, where we figured the block size out, well, we do know the block size. We know the block size is 32,768. And we know that the first subnet in this range, 10.0.0.0, is going to be exactly that, 10.0.0.0. However, when I have a number like 32,768, it's a little different than having a number like 32 or 16, where you can do that math in your head right away. So now we'll take a look at an optional way to figure out the subnet address. Now, this is going to require us to do some binary, but that's okay. We've got our skills in binary worked out very well here. And we've worked on them quite a bit in the course. So we're going to take the IP address and we're going to convert that to binary. And so here's what we're going to do. So 10 is going to be 0, 0, 0, 0, and then the 8 would be on, the 4 is off, the 2 is on, and then the 1 is off. So that's our first octet. Now, below that, we're going to put the subnet mask in binary. So we know that it's all ones, right? So this is kind of simple here. We know it's all ones. So now let's do, and let me mark this, and actually let me put it over here. So we'll say that this is the, try to keep it on the same sheet. This is the IP, and this is the subnet mask in dotted decimal notation. We'll put a little colon there for a separator. There we go. All right, so 101. Well, we know the 128 position is going to be off. 64 would be on. 32 would be on. That takes me to 96, meaning I only need 5 more. So what that means is the 4 position will be on and the 1 position would be on. So that's going to be 101 in binary. So now we've got 255. So again, very straightforward, very simple, right? It's great when everything's 255, sort of removes the mystery from what you're doing. Now to the third octet, 99. So again, 128 is not going to be on, but 64 and 32 is 96, meaning I only need 3 more. And that 3 is going to come from the 2-bit, oops, sorry, let me pull that back. The 2-bit position, the value decimal of 2, and then 1. And 2 plus 1 is 3, plus 96 is 99. And then here it's 128. Again, subnet mask, super, super easy to sort out the subnet mask. 0, 0. All right, we get to the last octet. Again, subnet mask, it's all zeros. However, 1, 2, 3, 4, 5, 6, 7, 8. However, when we get to the 228, it's gonna be a little work here, right? So 128 plus 64 is 192, plus 32 is 224. Now we wouldn't do 16 because that would put it at 240, right? So we're at 224 right now. So what do I need to get to 228? I only need 4 to get there. And so we'll turn on the 4-bit position. And then 0 and 0. And these are a little off. They're not lined up. But here is the best way, or I shouldn't say the best, but the quickest way to sort this out if we're going to manually try to figure out what this might be. And so here is what it would look like. We're going to do a bitwise AND operation. And here is how the bitwise AND operation is going to work. Is we simply compare the two binary digits, and if they're the same, right, then it's going to be that digit. So if it's both ones, it would be a 1. If they're both zeros, it would be a 0. But here's the interesting thing. If it's 0 and 1 or 1 and 0, it's also 0. So the only time we end up with a 1 in our result here from this equation is when both bits in the IP address that correspond to the subnet bit are 1s. And so we can kind of take a look here and sort this out. And it makes sense, right? That here in the first octet, that the first octet is going to be 10. But in binary, what does it look like? Well, 0 and 1 is 0. 0 and 1, 0. 0, 0. It's not until we get to the 8-bit position where they're both 1. 0, 1 is a 0. 1 and 1, well, it's a 1. And then 0 and 1 is 0. So what do we know? We know that the first octet is 10. So now let's work the second octet. And you can see here, both of those bits match up, and this guy matches up, and so does this guy. So if we work the equation out, 0 and 1 is 0, 1 and 1 is 1, 1 and 1, if they're both 1s, it's 1. Anything else is 0, right? And that's kind of how you can think of it. If it's not 1 and 1, if both bits are not matched as 1s, then everything else, it's going to be a 0. So 0 and 1 is 0, and then 1. So what is our second octet value going to be? Well, it's not 128 because that bit is off. So 64 and 32 is 96. And then we get down here into the 4, it's 100, it's 101, right? And you can see we've got that right there. So 101 for the second octet. And I'll put a little dot here. And now for our third octet. And we take a look at the third octet, kind of interesting, right? Nothing matches 1 and 1 between the two bits. There are no 2-bit positions here where both bits are a 1, meaning this is the next easiest value to figure out. We've got 8 zeros. So 1, 2, 3, 4, 5, 6, 7, 8. And then we come into our fourth and final octet. And if the bottom is all zeros, it doesn't matter what's in the top row. It's all zeros. And let me use some space over here. 3, 4, 5, 6, 7, 8. And it would be 0. And so we have our answer here that our address 10.101.99.228, this is my subnet address in dotted decimal notation. And we just simply do this bitwise AND, where if the two bits that line up in the IPv4 address when represented as binary and the subnet mask when we represent it as binary, if it's not 1 and 1, then it's a 0. Super easy. All right, so let's go ahead and let's type our answer in here. So we know that the network address is going to be 10.101.0.0. And remember, there's 32,766 available IPs in that range. So what is the IPv4 address of the first host on that subnet? Well, that's our network ID, so the first address is going to be 0.1. Now, what is the IPv4 address of the last host on this subnet? And so remember, if we've got our first host address and we know that it's going to be 32,766, it's going to be tough to kind of look at this and say, okay, well, then that would mean that the last address of, oops, sorry, I didn't mean to do that. And that would mean that the last address, if I just simply add 32,766, right? Because the block size of 32,768 makes it difficult here to try to figure out what that, excuse me, what that last address might be. Sorry about that, a little coughing there. All right, so it makes it difficult to simply just kind of add 32,768, but we have the subnet mask here. So we know the first address, and actually it might be easier to talk about the broadcast address. Oh, actually we'll do the last address first. So if this is the subnet mask, then the last address is going to bring us up to 10.101.127.254. And that would be our last usable address, right? Because we can see that the subnet mask starts here at 128, right? And then 0. So we know it would be 127 and 254, meaning my broadcast address would be 127.255, or 10.101.127.255. Now, this one was, again, a little bit more difficult, but we got the bitwise AND in there, and so we saw how we could quickly figure the network address out. And then what do you notice here about these values for the broadcast address when compared to the subnet mask? Yeah, if I add, what do I need to add to 128 to get 255? That's 127. That just happens to be the third octet. And what do I add to 0 to get 255? Yeah, 255. And that just happens to be the last, or the broadcast address. All right, so here are our values. So let me go ahead and type those into the worksheet. So 10.101. What are we asking here? The last 127.254. And then we're going to say 10.101.127.255. All right, so now let me go ahead and clear the screen here. And we're going to scroll down and take a look at problem number 3. So we'll bring number 3 into the fold here. And so now we're working with a Class B address. So we've worked with Class C, we've worked with Class A. Now it's time to subnet this Class B, which is a 172. And so we're also going to find out, we'll do a bitwise AND again and see what that looks like. But let's kind of speed things up a little bit here now that we're kind of familiar with the process. So number of subnet bits, well, we can take a look at the subnet mask and dotted decimal notation. And here I can say we have a total of the first octet, the second octet, that's 16 bits, and then we're borrowing how many bits out of that third octet? Well, we know that in the third octet, you've got 128, plus 64 is 192, plus 32 is 224, so we're borrowing the first 3 bits, meaning that the last 5 bits here in the third octet still remain as host bits. And then the last 8 bits in the fourth octet are all host bits. And I'll just say there's 8 host bits here. So here are the remaining 5 host bits in the third octet. This is our fourth octet down here. And so we're borrowing 3 bits. So there's a total of how many bits being used? Well, it would be 19 total bits used. And we borrowed 3 from the host bits in that third octet. So number of subnets created. Well, this is still an easy question to answer using that little cheat I showed you before, which if we only borrowed 3 host bits to make them network bits, we would say 2 to the 3 is 8. Let's get that equals in there. 2 to the 3 is 8. So number of subnets created is going to be 8. So number of host bits per subnet. Now here's where we're going to have a little larger equation that we're going to be working with. And that is we've got 8 host bits here and 5 host bits here. So there's a total of 13. Let's make a better 3 out of that. 13 host bits. So we'll say HB. So we would basically say 2 raised to the 13. And we should be, let's get our calculator out here and confirm. So if I say 2 raised to the 13, we end up with 81, whoops, bring the Word doc back. We end up with 8192. So 8,192 total IPs per subnet. Usable IPs, we have to subtract 2 for the subnet ID and the broadcast address, leaving me with 8,190. Still a pretty good size subnet. So total number of host bits per subnet, there's going to be 13 host bits. Number of hosts per subnet is going to be 8,190. So now we get down to the tough part, right? What is the network address of this subnet? So we can do the bitwise ANDing again, which is where we do the host IP in binary format. So 172 is going to be 10, so 128, 64, right? 64 would be off because if we added 128 and 64, we'd get 192. So 128, excuse me, plus 64 is not going to work because that would be 192. However, what about 32? Well, 128 and 32 is 160. Now I know I only need 12. So 16 is not going to be on, but 8 and 4 will, and that means that 2 and 1 are off. And so now what about the subnet mask in binary? Remember, we're going to be doing that and let's put that and up here, that bitwise and, where if it's not 1 and 1 between the two bits that line up, it's a 0, right? It's going to be super simple to figure that out. So all 255s, right? Pretty easy. We just put all 1s in here. And then we take a look and we ask, where do the 1 bits match up? Well, 1, 0, 1 and 1 gives us a 1, 0 and 1 is a 0, 1 and 1, 1, 1, 0, 0. So we end up with the same value as the host IP, right? Which we would expect, 172. And so we'll drop our dot in here. And again, this is just the binary representation product of this AND operation we're writing down here. And here is the decimal, dotted decimal representation of the product in binary. So let's come to the host IP's second octet here, which has a value of 22, meaning 128 is definitely off, as is 64 and 32, but 16 is on. So if 16 is on, I only need to get 6 more to get to 22, which means 8 is off, but 4 and 2 are on, and 1 is off. So we'll put our period there. And now let's come down to the subnet mask. Again, pretty simple, pretty straightforward here. And we should be noticing a pattern that when it's all 1s down here, it kind of matches up very nicely, right? We're not to the interesting octet yet, which is going to be this third octet over here. And so here you can quickly see that, well, okay, it's going to be 0, 0, 0, 1, 0, 1, 1, 0. It's going to be the same value in binary that the IPv4 address is, which we already know is going to be 22. Because up until this point, right, when all of the subnet bits are on, that means that these values that correspond to the octet that the subnet mask bits represent is going to be the same. And we see that here, right? So now we're at the interesting octet, which has a value of 32, which is going to be easy, right? 128, 64, 32. Everybody else is going to be zeros. Now, the subnet mask is 224. So 128 plus 64 is 192 plus 32 is 224, meaning the rest of these bits, 1, 2, 3, 4, 5, 6, 7, 8, and I did not line those up very well, but that's okay. The rest of these bits are going to be 0. So now we do a bitwise AND between the third octet of the IP. And again, this is my IO. This is my interesting octet right here, because this is where things change in terms of the subnet mask value. So 1 and 0 is 0, 1 and 0 is 0, but 1 and 1 is 1, and then we've got zeros the rest of the way. So this one's actually not going to be too difficult to sort out here. So 1, 2, 3, 4, 5, 6, 7, 8. And we know that everything else is 0 here in the 4th octet. So for the 4th octet, we'll do a 0. But what's the decimal value of that binary? It's going to be 32.0. Because again, that 4th octet, it's all zeros in the net mask and the subnet mask. It's all, excuse me, meaning if it's all zeros in the subnet mask, that it doesn't matter if this value up here is 255 in the IP or 254, it wouldn't matter. Everything would be 0 because it has to be, remember, you have to have a 1 in the bit position of the subnet mask and the host address in order for the value to be 1. So if any of these is all zeros, that means that the value when we do our equation is going to end up to be zeros. So here is the dotted decimal notation of the network address for that subnet. So let's go ahead and come back down here and say it's going to be 172.22.32.0. And we'll even drop in a /19, right? So that is the subnet mask for that address. We gave the dotted decimal, we gave the CIDR notation. So IPv4 address of the first host on the subnet. Well, that's the easy one, right? Because we take a look and say, well, if that's the network ID, there's my first IP, right? 172.22.32.1. The challenge now is going to come up when we have to figure out the last IP and the broadcast address. And so let me show you that trick that we worked on in the problem number 2, where we came up here and we said, okay, well, 224, what do I have to add to that to get to 255? Well, here we would add 31, right? And then what would I add to 0? Well, I would add 255. Now, here's the trick, right? So we end up with 31,255, but you can see that the network ID here, right? This is 32. So all you do is add this value to that value. Excuse me, in terms of getting the last IP address. So 32 plus 31 is 63, and then 255 would be that last value. We would add 255 to 0, and there is my broadcast address. I'll just say BC for broadcast address, right? So very, very straightforward. So 172.22.63.255. So let's go ahead. Let's fill these values in here. So the first IP is 172.22.32.1. And the last IP is 172, and I'll fix that, .22.63.254. And the subnet address would be 22.63 broadcast address 255. And so let's kind of highlight those there and see if we can't sort that out so that we can see our answers. And in here, again, the sheet is just not cooperating. So there we go. So there are your answers for problem number 3. Let's go ahead and continue on now. And let's take a look at problem number 4. So here again, very simple, right? And we should be able to handle this one with ease. So it's a class C, and lo and behold, there is our original classful subnet mask, a /24, and we've got it subnetted because we don't need 250, excuse me, we don't need 254 usable IPs. We need fewer than that. So we borrow from that last 8 bits, we borrow network bits to create more subnets. And so what does that look like? Well, let's just take a look. This is going to be the last octet. I'm going to say LO for last octet. And it would be 128 plus 64 is 192, plus 32 is 224, plus 16 is 240, 248, 252, right? And then the last 2 bits are off. And there's your 8 bits in the last octet in binary to get this value. Now, this becomes a very easy question to figure out in terms of number of subnet bits. Well, the total number of bits would be 24 plus these 6. So we would have a total of 30, meaning /30 in that CIDR notation. Number of subnets created. Well, we take 2 and we raise that to the 6th. And we know 2 to the 5 is 32. 2 to the 6 would be 64, right? So we've created 64 subnets that we can use. Now, in each of these subnets, how many usable host IPs are there? Well, it's 2 to the 2, and that gives us 4. That's total number of IPs per subnet. Usable IPs, we end up with 2. And these, a /30 is typically used on a point-to-point serial interface or on a point-to-point link between 2 devices where you only need 2 IP addresses. Serial interfaces, interestingly enough, you will typically find in larger environments where a /31 is being used instead of a /30. And we'll talk about this as we get further into the course. So these questions, very, very simple. Now, we also have the answer to an important question. That is our block size right here. Now, it's much easier to work with 4 than it is to work with 32,768, right? So if we start at 0, we just simply go up in increments of 4. So it'll be .4, .8, and we're going to have 64 of these subnets. Now, I am not going to do all 64 of these because take a look where we're going to end up here. So what we would want to do is we would want to try to figure out, right? And we don't need to do, you could do the bitwise ANDing here, but do we really need to do that? We probably don't. So we would be able to figure out by looking at that 244 is probably going to be one of the, because there's only 2 usable IPs, right? So if there's only 2 usable IPs, if the subnet is 244, can I divide the block size into that? Well, I can. So it would go in 61 times. So that would be the 61st subnet. So 4 into 244, divide it, you would get 4 goes into 24 6 times, and then 4 goes into 1 time. That's where I'm getting that 61, right? And so we would be able to look at that and say, okay, because then it would go to 248 for the next subnet, the 62nd subnet. The 63rd subnet would be 252, right? Because 48 plus 4, and then 61, 62, 63, and then we have the .0 subnet at the very beginning. Actually, this is going to end up, because if we started at .0, this would be our 62nd subnet to bring us up here to 252. So let's get rid of that. Okay, so we know that our subnet ID is going to be 244. And if we know that it's 244, again, 192.168.1.244, and we only got 2 usables, it's going to be 245 is going to be my first usable, and then 246. Another way that you could figure this out is to remember that in a /30, right, and I should say in all of the subnetting that we're doing here, the first usable IP will always be an odd number. So if 245 is the host IP in a /30, that means that the other IP can only be .246 because we can only have 2 usable here. And the subnet ID is always even. Always, always, always even. Your broadcast address will always be an odd number. Always. So subnet ID always even. First usable IP always odd. Last usable IP even. Broadcast address always odd. Again, always, always, always when we're subnetting. And so we've got our answers right here. Again, this one was a little bit easy, but that's okay. We'll take it. So number of subnet bits, the total, and I'll highlight this and change it so we can read it. And actually, let me do that right now. I still do not know why the sheet is behaving like this. All right, so total number of subnets. So we would say subnet bits. So total bits used is going to be 30. And we borrowed how many bits? Well, we borrowed 6 of the 8 of that last octet. All right, number of subnets created. Well, that was easy. We took 2 to the 6, and we got 64. And then the number of host bits per subnet, well, that's only going to be 2. The number of, the number of hosts per subnet, excuse me. And there it goes again, and it's going to be 2. And then we've got the network address of this subnet is going to be 192.168.1.244. And 245 is that first usable IP. Excuse me. And the IPv4 address of the first host on this subnet is going to be 192.168.1.245. We know that if there's only 2 usable and the first one is 245, and it has to be odd, that the last would have to be even, 168.1.246, meaning the broadcast address, which always has to be odd here, 192.168.1.247. All right, so those are our answers. Again, working with the Class Cs and when we subnet the Class C, much easier than a Class A or a Class B. The numbers we're working with are much smaller and easier to comprehend. So let's clear our screen. And let's come down to the penultimate one here, problem number 5. And I'm going to take a quick break here to get something to drink, clear my throat, and then we'll be right back. All right, so we're back. We're going to tackle problem number 5 now. Again, this one's going to be a little bit easier because of the fact it's a /24 subnet mask. Now, 128 by default is a Class B address, and so we see the default subnet mask for a Class B, and that's a /16, right? 255.255.0.0. And we're going to borrow 8 of the host bits in the third octet here to create more networks, because we want more networks with fewer hosts as opposed to fewer networks with more hosts. And so what would this end up looking like? Well, let's go ahead and work it out. So number of subnet bits, well, we're using 8 subnet bits, right? So if I say 2 to the 8, it's going to give me 256. So 2 to the 8 is 256. So the reason I wanted to put that out there is if we borrow all 8 of those bits, we've just created 256 subnets. Now, how many host bits remain? Well, it's 2 to the 8, right? So we've got 2 to the 8, which is also 256, and we're very familiar with the /24. We subtract 2 from the total number of IPs, and we're taking 2 away, 1 for the subnet ID, 1 for the broadcast address, meaning I'm going to have 254 usable IPs in that range. And so at this point, especially for number 5 at this time in our studies, we should be able to quickly come in here and say, okay, total or number of subnet bits. Well, I'll say, oh boy, here we go again with this. Let's highlight these. Let's turn it black here. All right, so we're going to say total bits, or she'll say total network bits. Total network bits is going to be 24, and we borrowed 8. All right, now I'm going to tab down, and hopefully the tab is going to work. Total number of subnets created, 256. We'll tab down. Number of host bits per subnet, 8. And of course, that didn't work. I'll fix it in a second. Number of hosts per subnet, again, usable, 254. Network address of this subnet. Well, that's already sitting right up there. It's going to be really easy, 128.107.0.0. And that is the network address of the subnet. IPv4 address of the first host on the subnet is going to be 128.107. 107.0.1. The last host address is going to be 128.107.0.254, right? Because we know that the last address, 128.107.0.255, is our broadcast domain. And now I apologize, let me highlight all of these and let's bring these into the fold here. Font size of 12 and in black. There we go. So that is what this one looks like, right? The /24s are very easy to deal with. And they're probably some of the more popular subnet scheme that you'll see used, especially with RFC 1918 addresses, where you kind of have sort of an unlimited number that you can use. Again, depending on your use case, I throw unlimited out there, meaning it's very rare that in a private network, you're going to exhaust all the RFC 1918 address space. All right, so there we go. That is going to be the answer to number 5. So let's clear our screen here. So now if we scroll down here, we're going to tackle the last problem, problem number 6. And this is going to be, again, very straightforward, very simple, because we see that familiar and comfortable Class C address, right? And there's this default mask for a Class C. In CIDR notation, CIDR, is a /24. And so what we're doing is we're simply going to be borrowing host bits out of that last octet and making them network bits. Again, the idea is we want more networks with fewer addresses. That is why you subnet, instead of possibly having fewer subnets with lots of addresses. All right, so 248. And if we look at this, what is 248 in binary? So what would this last octet look like in binary? Well, it would be 128 plus 64 is 192, plus 32 is 224, plus 16 is 240, plus 8 is 248. And then that would mean my last 3 bits, right? So I know right now 2 to the 3 is equal to 8. And there is my block size, right? That very important block size between my subnets. However, subtract 2 from that, and it gives me the usable number of IP addresses per subnet, right? So these are going to be smaller subnets with only 6 IP addresses for each of those subnets. And we know our block size is 8. How many subnets did we create? Well, 2 to the 5. We're going to end up creating a total of 32 subnets out of this 192.135.250.0/24, right? The classful boundary for that would have been a 192.135.250.0. And what we're going to see is we're now creating 32 smaller networks that can each accommodate 6 assignable, usable host IPs. So right now we've got all the information we need to sort of run through here and say, number of subnet bits. Well, total bits used is going to be, we borrowed 5, so it's going to be a /29. So total of 29 bits used. And we borrowed 5 of the host bits, and we made them network bits. So number of subnets created, again, 2 to the number of bits borrowed. We borrowed 5 bits. We created 32 subnets. Number of host bits per subnet. Well, there's 3 host bits per subnet. And you can see the text changing again here. Number of hosts per subnet. Again, this is number of usable assignable IPs. We know that value is going to be 6. Network address. Now, if we take a look up here, we're going to have 32 subnets. So if I was to try to do this by hand, and this is where you might get to the point of diminishing return and say to yourself, well, maybe that binary ANDing is going to be important here. And that's what we're going to do. Because if I was to try to work this out, I would say, okay, we start at .0, that's subnet 1. Subnet 2 is going to be .8. I'm sorry, block size is 8. I think I might have said 6. Block size is 8. So 0, 8, 16, right? I'm just going up in increments of 8. It might take me a few minutes before I get into the range where the subnet ID is greater than 180. So what if we did that little trick the binary ANDing we saw. And we know that it's all 255s in the first 3 octets. So really the interesting octet that we want to manipulate is going to be that last octet. So the IP of the last octet here is 180. Well, what is that in binary? Well, it's going to be 128. 64 would not be on because 128 and 64 is 192. But what about 32? That takes us to 160, 176, and now I only need 4 more to get to 180. So there we go. So there's my IP. Now let's take the subnet mask 4th octet, which is 248, which, hey, conveniently, take a look. We've got that worked out. 1, 1, 1, 1, 1, and the last 3 bits are zeros. So we manipulate this. We do our equation. We do that binary, or I'm sorry, the bitwise ANDing here. So 1 and 1 is 1, 1 and 0, 0. 1 and 1, 1 and 1, 0, 0, 0, 0. And now we have in binary that magic number we're looking for, which is the last the last octet, which is going to be this network ID, the network address of the subnet. In decimal would be what? 128 plus 32 is 160, plus 16 is 176. Did I say that right? Yeah, 32, 160, and 16 is 176. Now remember, you can have a total of 6 usable IPs, which means our first IP is 177. The last IP, well, just figure out what's 176 plus our block size of 8. Well, that's going to take me to 184. And that means my last usable here is my broadcast address is 183. My last usable is going to be 182. And so the usable range is 177 to 182. There's my 6 usables. And now we've got everything else we need to wrap this up. So 192, 168 dot, I'm sorry, 168, 135, 135.250 dot, and what are we doing here? The network address is 176. There we go. IPv4 address of the first host is 192, 160, I keep saying 168, 135, and was I writing 168 somewhere else? I'm just making sure here. No, okay, good. So 192, 135.250, first usable, 177. Last usable is going to be 192, 135.250.182. And that leaves me with my broadcast address of 192.135.250.183. Now this reflection question, why is the subnet mask so important when analyzing IPv4 addresses? And you've seen it here over and over again, right? The subnet mask is the gateway to finding out how many subnets I've created, how many subnet bits are being used, how many host bits are left over, how many hosts can I have per subnet. It all starts and comes from that subnet mask value. And then from there, we can figure out what is the network ID, what is the first host. So again, the subnet mask is the key to giving me all of these other values. And that is why it is so important. All right, well, this has been a monster tour of IPv4 subnetting, and that is going to wrap up Lab 11.6.6, where we calculate IPv4 subnets. All right, guys, thanks so much for watching, and I hope to see you in the next video.